Welcome to the class today on generating electricity. I'm Laura Lewis. Let's start with some learning objectives. Go to the next slide. So, number 1, describe the different methods of producing electricity, including fossil fuels, nuclear, and renewable. Number 2, understand how a generator works to produce an electric current from a magnet and a solenoid. And number 3, how to answer questions on electricity generation. Okay, so we talked about renewable and non-renewable. So what does that mean? So the definition here, so non-renewable means that there is a finite, so there's a limited amount of material that can be used as fuel, and one day it will run out. So coal, gas and oil have all got a limited amount. Okay, so one day they will run out. So the graph here is that this is the amount we have at the rate we're using. Okay, about people were using in 2011. So we'll see later that now we actually use less fossil fuels. So from 2011, it will only last probably not even another 50 years or so. So that means obviously we'll have to find a different way of generating electricity. So let's look at oil and gas for a minute. Okay, so oil and gas. So for millions of years, hundreds of millions of years ago, okay, underneath the ocean, so tiny ocean creatures called plankton died and fell to the sea floor. They were covered in sediments such as mud and sand and compressed. So planktons are tiny organisms, tiny plants and animals. Okay, so again, with little to no oxygen to break down the plankton. Millions of them, the plankton, were preserved in a sludge we know as oil. So in the North Sea, okay, there's oil, oil platforms that drill for oil. So gas sits on top of the oil. So you may know your house may be powered with gas. So that was where oil and gas comes from. So gas sits on top of the oil. So actually, coal comes from fossilized plants that died in swamps. Okay, but the thing is that while oil technically still is forming today, so coal isn't, but oil and gas are still forming, it's not forming faster than people are using it. Okay, let's just go over it. So energy resources are materials from which a form of energy can be obtained. So in many cases, the energy obtained is thermal, means you burn it, or kinetic. So we'll talk about that a bit later. We'll talk about generators. So, yeah, they have a finite lifespan, so eventually they'll run out. So there's two main types of renewable: the fossil fuels we just spoke about, the coal, oil, and the gas, so the gas hob, and there's nuclear we'll also talk about as well. So all fossil fuels, but mostly coal, okay, there's the steam trains that run on coal, have been used in fossil fuel power stations. The fossil fuels are burnt to produce thermal energy, okay, which produces steam and turns steam turbines to generate electricity. So we'll see a bit later about how that actually works, but it turns a turbine to generate electricity. So next one. So coal and oil fuels have been used in transport for centuries. So yeah, that's steam trains. That's in Victorian times, the Industrial Revolution. Yeah, from old steam locomotive trains to petrol cars. So the cars still use petrol, diesel, it's still, that's from oil, still a fossil fuel. So you may have gas, they said, from your home, and it's used in many homes to heat them. Okay. If you live out in the countryside, you might have oil actually. It's going to say in a tank. I don't have, I have gas in my old house, but I have oil in the tank. Depends where you live. If you haven't got a fuel line. So let's have a look at nuclear. So the main nuclear fuel is uranium. When uranium decays, it produces large amounts of thermal energy. Actually, if that's coming out of those cooling towers, actually only steam, which we'll talk about. The thermal energy produces steam and turns steam turbines to generate electricity. So really, a power plant that burns coal or a power plant that has nuclear fuel are actually more similar than they are different. Okay, so what happens here is that uranium gets very hot by nuclear reactions, Water is pumped around the reactor, which turns to steam because it's hot. And then you have a steam generator. Okay, so you've got some water in there. It turns a turbine. So turbines are like a big fan that turns a magnet in a coil of wire, turns a generator, which we'll go into a bit more detail later. But it doesn't really work in a different way to coal, really. It's still boiled water because it's hot and boils water. It's not that fundamentally different. Okay, so nuclear is a non-renewable, so it will run out one day, but it's got a lifetime of probably about 1,000 years. So often we don't give a lifetime, but it will last a lot longer. Okay, renewable. So renewable energy won't run out. So the first one, wind. Okay, the UK uses a lot of wind turbines, a lot of wind. It's quite a windy place. Okay, the UK, especially at the coasts. So another thing to note here is that all of these, okay, apart from nuclear, produce carbon dioxide. Okay, so that'll be in different videos to do with carbon dioxide in the atmosphere, but this is the note here. They'll produce carbon dioxide. Nuclear doesn't produce carbon dioxide. Okay, that comes out of that as just steam. Okay, that's just, there's not carbon dioxide coming out. But renewables like wind do not produce no CO2. So the blades of a wind turbine connects to another generator. That word again, generator. So I'm going to devote some slides to that a little bit later on. So as the turbine rotates, this causes the generator to produce electricity. So again, we're turning a turbine. So all of these technologies, in the end, turn a turbine to produce electricity, or a generator. Okay, generator is the whole thing, and one part of it is called the turbine. So the faster the wind speed, the more electricity is produced. Okay, that's obviously overall, but of course wind speed gets too much, you can break the wind turbine. Depends how they're made. So it's a good things and bad things about them. Produce no carbon dioxide, low maintenance, they don't have to be actually fixed that often. Okay, some people say they're noisy, if you get close to them, they're quite noisy. Visual, I think they look quite nice, but that's opinion. But this is not an opinion. If there's no wind, there's no electricity. So you could say they're unreliable, but it depends where you put them, because some places are always windy. Okay, solar power. We've got two types of solar power. The first one is a solar panel. All of that does is quite simple, is that cold water comes in, the solar energy, so the sun shines on it and it heats the water in the solar panel and hot water comes out. That's called a solar heating panel. So that's not producing electricity. I put it on here, it's not producing electricity. This one, however, a solar cell, produces electricity. So sunlight comes in here and it creates a current in the special material called a semiconductor. Okay, that's actually not turning a turbine. So solar cells are probably pretty much the only one that don't turn a turbine. So they produce, they're called photovoltaic cells, okay, which means light to electricity. Okay, directly convert, so they directly convert sunlight into electricity, which use to power usually small objects. They're getting bigger and more efficient, but at the moment they usually use to power small objects, usually. Again, they produce no carbon dioxide, potentially infinite energy. Yeah, that's true actually, because remember the sun's always there, and if sometimes it's cloudy. The UK is not an ideal place. A place like the desert, where it's pretty much always sunny, is potentially infinite. Yep, another thing is that single houses can put them on the roof. Okay, so sometimes you might see people with solar cells or solar panels on their roof. Okay, but at the moment they can be quite expensive to produce and to install. But again, that cost is coming down all the time. Hydroelectric, you may know some geography, okay, because some places have rivers and they build a dam. So it's just a structure to block the water. Okay, so it's stored in a storage tank, or sometimes a natural river called a reservoir. Sometimes you can build them. Okay, so when the water's let through, so there's like a sort of gate here you can let through, it again turns a generator which produces electricity. So the further this water falls, the more electricity it will generate. Okay, so as the water flows through, it rotates the blades in the turbine again. So it produces no carbon dioxide, creates water reserves as well as energy supply. Yep, so this could actually serve a sort of town or sort of around it. So again, we think about how big some of these dams are. Okay, you can see something like the Hoover Dam, very costly to build. And if they go wrong, you have to be careful how you build them. They can cause flooding or if that breaks. You have to be careful how you build them. Okay, wave power, again, we've got this a bit in the UK too. We've got lots of coastline. In this one, you've got a generator inside it, and the waves rock it back and forth. So it's not a huge producer of electricity wave power. Okay, it's for small things again, usually. But the rocking actually causes a generator to work. Okay, obviously the more waves are on, more electricity is produced. Geothermal, again, we don't have this in the UK. We haven't got volcanic rocks, but places like Iceland use this a lot. Okay, so geothermal energy is produced from radioactive activity deep underground. So it's not nuclear, this is natural rocks that are hot underground. Okay, so the rocks are hot. So water is pumped down, okay, into pipes down here, and it comes up because it's the rocks that are hot naturally, the natural thing underneath. And the hot water turns to steam, it gets really hot, and that again turns a turbine. So it's kind of a little bit more like a traditional power station using the natural environment. Again, it produces no carbon dioxide. Yeah, in certain places, it's potential infinite energy supply. So in certain places. So again, this is only work in countries where volcanic activity is high. It only can be in certain locations, this one. And geothermal activity unreliable may die down. And also, yeah, radioactivity of geothermal activity. So yeah, there could be contamination issues, even from a natural source to do with this. Okay, but I think the main thing is only certain places can use it, but where it can be used is actually very effective because they do use it in lots of places. Okay, so the interesting thing here is that for the first time, okay, the UK takes a lead for the first time, renewable energy. So if you look at this little circle, it was in 1990, 3/4 pretty much of our electricity was from coal. If you look to not 2019, it's getting smaller every year, only a tiny fraction was coal. Nuclear was quite a big fraction, but wind and solar and hydro were tiny. Look how big they are now. Okay, so renewable energy is really becoming more common. So you've got a nuclear, that doesn't produce CO2, so it's not really a problem. Okay, biomass, that's you can use lots of different types of crops are grown for biomass to burn. Some of it's waste food burn. I live somewhere where there's a power plant that burns waste food, biomass stations. Coal is again small gas is still quite, it's quite a big proportion still. Okay, but I think yeah, it's going down quite a lot. Wind is actually getting a lot more common, especially on certain windy days. Okay, so we're talking about generator effect. So what is it? Okay, so it's when you can either have two things. So either the wire moves between two magnets, or a magnet moves relative movement in a magnetic, in a wire. Okay, so in the generators we saw, the power stations, okay, that the magnet is moved in a wire, so it's spun round inside the coil of wire, or the coil of wire is spun round. Okay, it's called relative motion. So when an electrical conductor, like a wire, is moved central to a strong magnetic field, the movement of the conductor crossing through the magnetic field lines creates a potential difference at either end of the wire. So this is called electromagnetic induction. So if the conductor is part of a complete circuit, the induced potential difference, so otherwise voltage, causes current to flow from one end of the circuit to the other. This is the generator effect. So that means that the relative motion, so that means that they're moving relative to one another, of a magnet and a coil produces electricity. That's the generator effect. Okay. So I put this up here. Okay, when I say U-shaped magnet, that's a U-shaped magnet there. So to copy and complete using the slide before and anything otherwise, to copy and complete this paragraph. Okay, so I'll let people just sort of stop for a minute and then I'll go through it soon. Okay, so here are the answers. When an electrical conductor is passed through a U-shaped magnet, the conductor crosses through the magnetic field lines. So let's look at the magnetic field. They're drawn there, light blue, magnetic field lines exerted by the magnet. This movement causes an induction of potential difference, another word for voltage, at either end of the electrical conductor. This is called electromagnetic induction because the electrical conductor interferes with the magnetic field, inducing the change. The electrical conductor being moved is a wire in a circuit. The movement of the wire causing an induced potential difference allows the current to flow from one end of the circuit to the other. This current flow is called the generator effect. So in addition to moving wire, for a magnetic field producing a generator effect, a moving magnetic field across a stationary wire also produces a generator effect. So that means that you have any relative motion. Okay, thank you for joining this lesson. Hope to see you in another one very soon. Thank you, goodbye.